Good morning, I am Renu Sharma, Assistant Professor, EC Department. Today I am going to start with the next unit, that is unit 4th, and this is related to multiplexing. So, first we will see what is multiplexing. So, under the simplest condition, a medium can carry only one signal at any moment in time. So, basically whenever we are going to set up any connection between the transmitter and receiver, let's say this is one transmitter, one receiver, and a channel is being set up. So, generally in the simplest manner, this channel will only going to connect one transmitter and one receiver, that is known as point to point communication, which means that this is the only one user can transmit the information. But in case of multiplexing, where more than one user can use a common channel, then that is known as multiplexing. More than one user or two user can use a common channel. So, that is application specific, that is the case that we are using in broadcasting. So, if we try to pass multiple signals through a common medium, then they will possibly interfere with each other. So, there is another problem that will occur whenever more than one users are using a common channel. So, that is the case. Let us say there are 4 different users, user 1, user 2, user 3 and user 4. The signal of all these 4 users will be multiplexed together, and then there will be single channel, and then these 4 signals will be delivered to 4 different receivers. So, that is the case. But what happen that when these 4 signals are multiplexed together, these signals are going to spread. So, that is the basic nature of the signal when it is traveling over a channel, that is spreading of the pulse. So, when these pulses will spread, then there will be a problem that is known as intersymbol interference that will occur, that will cause the loss of information. So, that is has to be taken care of in case of multiplexing. So, this means that we have to devise a way to avoid the interference of the signal. So, which means that multiple signals should have different frequencies, it must not travel at the same time, and it must not travel through the same medium. So, these are some of the options that are available to avoid this intersymbol interference. Let us say first one, that is having the different set of frequencies. So, there are 3 different users. So, set of frequencies allocated to the first user U1, that is 0 to 2 kilohertz. Second user is allocated 2 to 4 kilohertz. Then third user 4 to 6 kilohertz. So, if you are going to calculate the bandwidth of each of the user, it will be upper limit minus lower limit. So, that will be the 2 kilohertz of bandwidth each user is having. So, the signal will going to be multiplexed together, and then a signal will be generated. So, this means that different set of frequencies is allocated to different users to avoid the case for intersymbol interference. So, for multiple signals to share a medium, the medium must somehow be divided so that each signal receives a portion of the total bandwidth. So, that is the case of multiplexing. Now, why we need multiplexing? Because since there are some problems related to multiplexing like the intersymbol interference. So, basically why we require multiplexing? So, transmission services are very expensive, like the leased line or the packet switch network, which means that whatever channel that we have set up between the transmitter and receiver, it can be connected, it can be connection oriented, it can be connectionless, means wired or non-wired. So, in both the cases this cost is quite high. So, let us say 4 users want to transmit the information. So, instead of using 4 different wires, we can use a single wire, so that they can accommodate the common channel. So, multiplexing and compression techniques save the business money basically. So, compression means we are going to compress the multiplexed signal so that the bandwidth will be reduced for transmission, and that can be delivered to the receiver side without any intersymbol interference. Also, as the data capacity of line increases, it will become more cost effective for a company. Let's say I am taking a very small example. For let's say 100 of users wants to transmit information from one place to another place, then instead of using 100 different wires or 1000 different wires, we can use a single wire or 2 wires, so that they will cost cutting is directly reduced. Most data services require modest data rate support. So, these are some of the advantages why we need multiplexing. Now, next is we have discussed about multiplexing. Now, how this multiplexing will be done? So, it is based on two different criteria, like first one is the frequency division multiplexing, second one is the time division multiplexing. So, in case of frequency division multiplexing, the frequency is the total available frequency. Let's say I have allocated I have made up a system and allocated 100 kilohertz of frequency to 10 different users. So, this 100 kilohertz of frequency should be equally divided among 10 different users along with the guard band. So, guard band is basically inserted between two different users to reduce the intersymbol interference problem or any kind of problem that will occur due to the spreading of the pulse when it will travel over the channel. So, that is the case of frequency division multiplexing in the simplest manner. In case of time division multiplexing, whatever time is allocated for the whole transmission of information, it should be equally divided among different users. So, that is the case of time division multiplexing. Now, this is the diagram, the basic notation of the mux. In short, multiplexing, it is known as mux. It is nothing but sharing of medium. So, at the transmitter we have to use a multiplexer, at the receiver we have to use a demultiplexer, that is the opposite part of mux, like modulation and demodulation. Then sometimes it is just called as mux or demux. So, this is like n number of users can going to accommodate over the single channel. You can see over here one link is there. So, this is n is to 1. Output of this mux will be there and this will be 1 is to n, which means n number of users and n number of receivers are there and there is one single channel. So, that is the case for mux. Now, we will come what is FDM. A frequency spectrum is divided among multiple logical channels. Each user can have access to its own assigned frequencies or logical channel at all the time that the individual user is active. So, let us say I am taking an example of 3 users like U1, U2 and U3. These 3 data has to be multiplexed together using a mux. So, this will be a mux and then here we are having this is n is to 1 and here we are using demux. So, there will be receiver 1, receiver 2 and this will be receiver 3. This will be one channel. So, this is having frequency 0 to 2 kilohertz. Then I will take 2.2 to 4.2 kilohertz. Then 4.6 kilohertz to 6.6 kilohertz. So, basically what I did, I have inserted guard band after every user. You can see that 0.2 kilohertz of difference is there, and if you are going to calculate the bandwidth of each of the user, it will be 2 kilohertz, but after this 2 to 2.2 there will be a 0.02 kilohertz of space will be there. So, this will be 2 kilohertz for first user, this will be 0.2, then again this will be 2 kilohertz, this will be 0.2 of spacing will be there. So, this will be U1, this will be U2, again this will be U3, this will be 0.2. So, this is how the you can say the frame will be formed, and this is how the information will be transmitted. So this is the case why I have inserted to avoid the intersymbol interference over here. So this is the main concept of FDM. Each user can have access to its own assigned frequencies or logical channels at all the time that the individual user is active. Now this is the representation. Now you can see that this is a diagram, logical diagram, time versus frequency, and each channel is having a center frequency, that is F1, F2, F3 up to F6. These are the different channels, and F1 is the lowest frequency of the band, F6 is the highest frequency of the band, and Fn is nothing, it is the subscriber frequency that we are having. So it will sense the signal in several distinct frequency ranges. Each signal is modulated on different carrier frequency. So when we are saying that there are 3 different users, so 3 different carrier frequencies is also required at each end, so that these 3 signals initially these are modulated to different frequencies. The bandwidth of the transmission medium must exceed the required bandwidth of all the signals. So that is the case of FDM. Now it is used in cable TV to carry multiple video channels on a single cable network, broadcast radio and TV, and the amps, that is 1G kind of generation, first generation wireless communication cellular phone systems use FDM. So initially FDM is used by the first generation, and second generation, that is GSM, is using less of FDM, it is using more of TDM. So FDM is specified for first generation networking only, where we are only transmitting the voice signals, we are not transmitting or not using it for data signals. So since it involves analog signaling, it is more susceptible to noise. This is the oldest technique of the multiplexing. Now next it is showing the FM transmitter and receiver diagram. Now you can see over here that there are n number of message signals or n number of users are there. Each are having their own carrier frequency, subcarrier frequency centered at F1, F2 up to Fn. These are having their own frequencies. These are multiplexed or sum up together, and then we are having a transmitter and an FM signal will be generated. So spectrum of the composite signal, as you can see, so this is known as guard band, which has been inserted so that whatever dispersion of the pulse which is taking place, it will not coincide with the second user or not coincide with the consecutive user, which will cause the loss of information. Now next is, this is a description of the FDM transmitter. Each user is assigned non-overlapping frequency ranges so that multiple signals can be transmitted at the same time. Multiple message signals like M1T, M2T up to MNT from multiple sources are modulated over different subcarrier frequencies and send them to the adder. Now this composite signal is modulated over a carrier frequency and transmitted over the channel. Now next one is the FM receiver. So this is a diagram of receiver where the composite signal will be received, then it is being divided into n number of paths, which is being, first block will be the band pass filter. Now it is passed through S1T up to SNT. Then this will be the demodulator where different frequencies are there like F1 up to Fn, and these are the different receivers are there, n number of receivers are there. So that is the case for FDM receiver. This is the description of the FDM receiver. Now we will see what are the disadvantage of FDM. So the problem with FDM is that it cannot utilize the full capacity of the system. So we need to ensure that the adjacent bands do not overlap with each other. So otherwise the signal in the band may interfere the signal with the other band. So to reduce the case of this FDM, we are using this TDM concept. Now we will see what is TDM. So in time division multiplexing, the time is divided into multiple smaller units called the slots, and each user is given a slot to transmit the signal. So this is how we are going to allocate. Let's say I have 10 minutes of time for transmitting the information. So this is user 1, this is user 2, this is user 3. So this 10 minutes is equally divided into 3 different users. Let's say it will be approximately around 3.5 2 or 3.3. So this will be the case. The remaining will be act as an guard interval. So for 3.2 minutes, for the first 3.2 minutes, the whole channel will be used by the first user, and for the next 3.2 minutes from this total time, it will be used, the whole channel will be used by the second one, and same with the case with U3. So this is how the whole channel will be used by a single user at a time for a specific time of interval, so that the greater information can be transmitted. So each user has the entire bandwidth of the channel for a short interval of time. So whatever channel bandwidth we are having, it will be totally accessed by only a single user at on a specified point of time. Now this is the logical diagram. This is time versus frequency. Now you can see over here that time is equally divided among n number of channels, means n number of users. Now it is used for the digital signal or analog signals carrying the digital data. Data rate of the transmission medium must exceed the required data rate of all the signals. Clock synchronization is one of the major issue in TDM. So what is clock synchronization? So for this TDM we require a sampling sampler, and to operate the sampler we have to assign a sampling frequency. Now sampling frequency is denoted by Fs, and its inverse will be is equals to Ts, that is known as the sampling time. So when we are doing the modulation at the transmitter side and demodulation at the receiver side, this Ts has to be set to a value so that it will take the samples at equal time interval. So that is known as clock frequency. So whenever the clock which is used at the transmitter and receiver not running at the same frequency or not working at the same point of time, then the synchronization is not maintained and there will be loss of information. So in this case we have to take care of the clock synchronization. So this is the synchronous TDM system, you can see. So in this case, synchronous TDM is multiplexing process, where you can see that this is mux. There are 4 different users which are connected. You can see that there are 4 bits for user 1, 2 bits for user second, 1 is for this one, and 3 bits are there for user 3. So all these signals has to be multiplexed together, and in case of this TDM, frames will be formed. So 4 frames will be formed, like first frame is having all the first bits of 4 different users, frame 2 is having. Now since only 1 bit is associated with the third user, so this space will be vacant, and this is how we have to transmit. It is not the way that we can reduce the frame size. So this is the case for synchronous TDM. Now next one is the asynchronous TDM. So in this method, slots are not fixed. So you can see that whatever I have shown you in the earlier slide, that these vacant spaces, these are removed in case of asynchronous case. So first frame is having 3 bits, second frame is having 3 bits, and you can see in the fourth frame these are left vacant, or these has to be not to be transmitted. So that is the case. So in all the first 3 frames, no space is sent as a vacant space. So that is the case for asynchronous TDM. Thank you.